polynomial inequalities and absolute values. So we're going to first start off with polynomial inequalities. So a polynomial inequality is very similar to a polynomial equation. The only difference is you're using an inequality symbol. So there's greater than, less than, greater than and equal to, and less than and equal to symbols. Okay? And if you can solve polynomial equations, then you can solve polynomial inequalities, except for one rule, and we'll talk about that in a second. So when you're solving a polynomial inequality, and again, this is what makes it an inequality, this greater than and equal to sign. The only difference is you're finding a range of answers as opposed to just a single answer. Okay? But you solve it exactly like you would an equation. So if I wanted to isolate the x in an equation, I'd bring the 2 to the other side, excuse me, the other side, and collect like terms. And then I don't want 3x, I just want x, so I divide everything by 3, and I get my answer. So any single x value that is greater than or equal to 7 over 3 would make this inequality true. Does that make sense? Okay. So negative 2 bracket 3x minus 1 less than 4x minus 8. So again, solving a polynomial inequality is like solving a polynomial equation. Like this is no different than an equation you would have seen way back in grade 9. So the first thing you want to do is distribute. So I get negative 6x. And negative 2 times negative 1 is positive 2. I'm getting a lot of people making those silly mistakes on tests. Just take your time and really think about what you're doing. Okay? Because unfortunately, with these types of questions, if you mess up a negative sign, then everything other underneath it gets messed up. Okay? You're not going to get the whole question wrong, but you're going to lose some parts, right? Okay, so now bringing the x's to one side, just like you would an equation. Bringing the numbers to the other side. Like that. Simplifying by collecting like terms. Dividing by the coefficient in front of the x, because you don't want that. And this right here is the new part. Whenever you divide or multiply by a negative coefficient, then the inequality changes direction. And that's really the only thing you have to remember for inequalities. It's just like solving an equation, but when you multiply or divide by a negative, you change the direction. When you multiply, divide by a negative, change the direction of the inequality. So that's really the only part you have to remember. Okay. The next part is inequality with fractions. And this is always a part that messes people up for some reason. But dealing with fractions in equations or inequalities is just a matter of identifying the common denominator and then multiplying all the terms by the common denominator so you don't have fraction anymore. Okay? Then it just becomes an easy question like this one. So you look at here, you look at the denominators. Okay, so there's 2 of them here. The common denominator is 12. So I'm going to multiply everything by 12. Now it's important whenever you have a term that's a rational term that you have something greater than a monomial here. It's a good idea to put that binomial into brackets. Okay? So I multiplied my first term by 12. I multiply my second term by 12. And again, it's a good idea to put this into brackets. And then I multiply my other term by 12. The most common mistake people make is they forget to multiply the other side by the common denominator. Okay? They do this in the guide. They do it a little bit differently. Okay? You can do whichever way you prefer. I prefer this. It makes a little bit more sense to me. So the whole purpose of multiplying everything by the common denominator is to get rid of this number. I can get rid of it because I can say 3 goes into 12 4 times. So if you're doing it this way, and you really should, okay, actually cross out the 3 and cross out the 12 and put your answer above it. Okay? Now this is why it's important to put your numerator in brackets, because now you're taking this 4, multiplying it by both terms, not just the first term. And that's another mistake people make if they forget to put the numerator in brackets. So I get 4x minus 16. Exact same thing for the next term. 4 goes into 12 3 times. Remember, I'm multiplying in a negative 3 because of this minus here. So I get negative 3x minus 3 is greater than or equal to 24. So that first step, identifying the common denominator and multiplying everything by the common denominator, you shouldn't have any fractions in the next step. You're done. Okay? Now it just becomes an easy questions like the ones we've been solving. Collect the like terms. X is greater than or equal to 43. Any questions on that? So that's about as hard as or easy as it's going to get. Okay? Solving an inequality, solve it just like an equation. The only thing you have to remember is when you multiply or divide by a negative, it changes the direction of the sign. And with the fractional ones, multiply everything by the common denominator, and then divide it through, and then write an easier polynomial inequality to solve, and then solve it. Any questions on that? Okay, so that's it for polynomial inequalities. The next thing we're going to look at is absolute values. So we'll first define what an absolute value is, and then we'll do some examples. Okay, so by definition, the absolute value of a number means the distance, regardless of direction. It doesn't matter where the number is. So the distance, the number is away from the origin. And then the notation for absolute value is 2 elongated lines. Okay, so a couple of examples. Evaluate. Okay, so the absolute value of negative 8 means how far is negative 8 away from the origin in distance. Okay, so graphically, what I'm asking, and you don't have to do this, I'm just showing you. So here's the origin, 0. Here's negative 8. What's the distance between these numbers? Yep, 8. In layman's terms, people think of the absolute value as getting rid of the negative sign. And that'll work, okay? But really remember that when you see an absolute value, it's really talking about the distance. Does it make sense? Okay, and when you have multiple absolute value signs, something like this, evaluate your absolute value first, and then multiply it by the number in front. Okay, so you cannot distribute this. It's not like a bracket. Okay, this is a function. So you can't take this and multiply it in. That doesn't make any sense. So what you would do is collect like terms inside of the absolute value, then evaluate the absolute value. The absolute value of negative 7 is positive 7. And then simplify your expression. Make sense? Okay. So ultimately, we want to be able to solve absolute value equations and absolute value inequalities. So let's start by doing some easy ones that we can just do by inspection. And then I'm going to show you a process for solving the harder ones. So example. So this question is saying the absolute value of x is equal to 5. What are the answers for x? Here. So the two x values that would make this equation true is x is equal to -5 or x is equal to 5. Make sense? Okay. What if I ask that question? Okay. Right, you can't do it. Because there's no way that you can take a number, take the absolute value, and get a negative answer, because the absolute value, by definition, means the distance. And you can't have a negative distance. Okay? So you'd say no solution, or does not exist, or can't do it, as long as you articulate to me that that question can't be answered. Okay, so now we're going to get into solving the harder absolute value inequalities and equations. In order to do that, we're going to talk about the mathematical definition of an absolute value. Okay. By definition, mathematically, what changes my answers to positive is if the absolute value is equal to -x, if x is a number less than 0. So if x is a negative number, then this negative is going to change it into a positive. And that's going to end up with a positive. And if x is a positive number, then it's going to stay a positive number if that makes sense. But this is the important part, is there's always two cases to absolute value equations. There's two cases. There's the negative case, which is that guy, and the positive case. So really the trick for solving absolute value equations and inequalities is just remembering that there's two cases. Okay? And that is by far the most common mistake people make on a test, is they just do the one case. Okay? So if I have a question like this, so question B, so we're still under the heading of this example here, solving, so actually you can see. So I want you to find out the values of when the absolute value of 2x minus 3 is equal to 16. As soon as you see absolute values, you should be thinking your two cases, the negative case and the positive case. So case 1 is the negative of the absolute value. So when you're writing down your first case, you write down the negative and you put brackets around the absolute value. Do not write the absolute value anymore. If you do that, that's wrong. Okay? And then you just solve this. So then negative 2x plus 6 plus 3 is equal to 16. Negative 2x is equal to 13. My first answer is negative 13 over 2. So if you put negative 13 over 2 into here, times by 2, subtract out 3, you get 16 as an answer. My second case is the positive case. So I just take the absolute value, what's inside it, and write it down with a positive sign in front of it, but a positive sign doesn't change anything, so I just write down what's in the absolute value, and then I solve this. So my other answer is 19 over 2. So really the hard part of solving absolute value cases, and these questions aren't hard to solve, right? These are just easy grade 9 questions. It's just remembering the two cases, okay? Your guide does it a little bit differently, Okay. If you do it my way, you will never forget to change the direction of the signs, which is important when you're doing the inequality ones. Okay. If you do it the way the guy does it, doesn't matter, but so now we're solving absolute value inequalities. Okay, so it's done the exact same way as the equations. You just have to break them up into the two cases. So case 1 is the negative case. So you take the negative of what's inside of the absolute value. Again, do not write the absolute value, because as soon as you break it up into the two cases, you're losing the absolute value sign. So that's your first case, and then you can solve it. So negative 3 plus 9 is greater than 12. Negative 3 is greater than 3 when I bring the 9 over. Divide both sides by negative 3. And remember, when you divide both sides by negative 3, you're going to change the direction of your inequality. So any x that's less than negative 1 is going to make this polynomial inequality true. Now I have to find the other branch by doing the positive case. And for some reason I wrote that down wrong. Sorry. I wrote the inequality sign in the wrong direction. Just created it. There. Okay, so there's my other branch. So my answer to the question of when is the absolute value of 3x minus 9 greater than 12? It is greater than 12 when x is less than negative 1 and when x is greater than 7. So I'm going to write it now into a nice answer. X was greater than 7 and x was less than negative 1. Does that make sense? I'm going to tell you it doesn't. Can somebody tell me why it doesn't? If you wrote that on the test, you're going to lose marks. Because this says x is less than negative 1, which I wrote. X is less than negative 1, and x is greater than 7. X is greater than 7. It seems right. Why is it wrong? See? Exactly. There's no number in the world that's greater than 7 and at the same time less than negative 1. Okay, so you cannot write it like that. If you wanted to write your answer, you would say the answer to this question is x is less than negative 1 or x is greater than 7. Okay, I get a lot of people writing this and it doesn't mathematically make sense. Okay. So let's just try another one, because it doesn't matter if there's x's, it doesn't matter where the absolute value sign is. What matters is that you remember that as soon as you see an absolute value, whether it's an equation or an inequality, you think, I have to do two answers. I have to do the negative answer and I have to do the positive answer. So the first case is the negative case. So I write down the negative of what's inside of the absolute value, and everything else stays status quo. Once I've done that, then it's just an easy equation to solve, or inequality. Negative 3 plus 1, 2 minus 8, negative 3 minus 2, this becomes minus 8, I believe. Negative 5x is greater than or equal to negative 8. Divide both by negative 5. And I get x is less than and equal to, because I have to change the direction of the sign, 8 over 5. So my first answer is x is less than 8 over 5. Now my next case is when I write down the positive of what's inside the absolute value. Collecting like terms on either side. X is greater than or equal to negative 6. So now this one, I can combine into one inequality statement because this is saying x is less than 8 over 5 and equal to, sorry, and x is greater than negative 6. So that falls in a range, so I can do that because I can find numbers that are less than 8 over 5 that are the same time greater than negative 6. That make sense? Okay. And that's all there is to polynomial inequalities and absolute inequalities and equations. Okay? So basically your first page of your test is exactly what I've done here. Okay? There's no tricks. I'm not trying to trick you on the test, right? Remember, and I guarantee the people probably not listening to me right now are not going to do the two cases for the absolute value. Okay? That's the hard part for these questions, is making sure that you do the two cases. And the only thing else, which is new today, is that when you multiply or divide by a negative in an inequality, you change the direction of the sign. Everything else is just grade 9. Any questions? Okay, so I'm going to stop this. I'm going to post it.